In order to explain this problem, I kind of need to go a little bit more in depth because it's asking you to determine whether it's even, odd, or neither. So I have to explain all that. So I've just come up with 3 random problems that I made up on my own, color coded it. The purple area is where I'll talk about even functions. The yellow is where I'll talk about an odd function or give an example of an odd. And then the blue turquoise is where it's an example where it's neither even or odd. And if you have an even function, it's called even because it has symmetry, and that symmetry is around the y-axis. The best way I can explain this is, do you remember when you were in elementary school and you would take a piece of paper and fold it in half like that? And then you would draw this on it? And then you would take scissors and cut along that. Usually you would do this around Valentine's Day. And then when you opened up the paper, you had a perfect heart. That is symmetry. The edge of the paper where you fold it in half, which creates the right side of the heart, when you open it up, you get a perfect match to the left side. Now my drawing sucks, yes I know, but if you remember doing this, I'm sure you do. So when I'm looking at my purple picture here, the parabola, it's symmetric around the y-axis, because if I took, go with the green, if I took this side here and folded it over, it would land perfectly on the other side. They'd match up. That's symmetry. Now, to test for symmetry, to see if this really exists, what you basically do, if you look at the x-axis, if you're to the right of this point here, if you're to the right of the y-axis, this is where all your positive x are. If you're to the left, this is where your negative x's are. And if you plug in the negative number that would be the opposite to this positive here, it should have the same y coordinate and match up at the same height to show that you have symmetry. So all you have to do is say, okay, what if I plugged in f of negative x? That's going to be 2 times negative x squared, and then you simplify it to see if it comes out to be the exact same thing that you started with. So this is, when you take a negative x and square it, you're taking a negative x times a negative x. Well, a negative times a negative is a positive, and x times x is x squared. And then I can't take 2x squared minus 3, and what I'm left with is 2x squared minus 3, which is exactly what I started with. So by plugging in a negative value, you would get the exact same thing that you would get if you plugged in a positive value. So that proves to me that this one is definitely an even function. Now for the next one, if you have an odd, I'm into the yellow now. Odd functions also have symmetry, but it is to the origin. And you'll notice up here on the even one, I forgot to point that out, the symmetry is what I refer to as a single vertical fold, just like the heart. If you are doing an odd function, which is in yellow, you're actually going to do a double fold, one vertical and then one horizontal, which is harder to show on a piece of paper like this where I'm drawing. But if you look down here, if I were to start by taking this right side and folding it over to the left side, it would look like this over there. But then I have to flip it, so it's like you're folding the paper once and flipping it over, well, not even folding, I'm flipping it over to the left. And then if I flipped that upside down from there, okay, so now I want to flip it one more time, flipping it around the x-axis, you're actually flipping it around the y-axis first and then flipping it around the x, and now it's going to land on top of this. It's hard to draw this, but that's what they call symmetry around the origin, because you can't really fold at a point. So it's more like flipping. I guess I shouldn't say double fold, I should say a double flip up here. Okay, so when that happens, like for example, this point right here, which is in quadrant 1, it has a positive x and a positive y. When you flip it down here, when you do the double flip, it ends up in quadrant 3, which has a negative x and a negative y. So just like before, I'm going to plug in a negative x into the function and simplify it. Okay, so this is negative 3 times negative x times negative x times negative x. And then I still have the plus 2 times negative x. So I've got negative times negative times negative times negative. That's going to be a positive 3x cubed. But then back here, a positive times a negative makes that a minus 2x. If I compare my functions, I have a negative and then a positive. It has switched to a positive and then a negative. That's the double. They both have to change. Now your book will talk about if f of negative x equals negative f of x, then it's an odd. That's because if I were to pull a negative 1 out of this, I'd have negative 3x plus 2x. And you can see that this is identical to this, but there's a negative 1 in front. If the sign, I just look at the signs. If the signs change, if they both change, it's odd. And that's the symmetry around the origin. And then the last one, and I just made this up, and I don't even know if that's really what the graph looks like, but you can tell that if you were to fold it along the y-axis, there's clearly no symmetry there. And if you did a double flip, once around the y and then once around the x, that doesn't match up either. So it's just not. And what will happen is you'll do the same thing on this. You'll replace it with a negative x and do the math. So this is going to be 10 times a negative x cubed. Negative x times negative x times negative x is a negative x cubed. And times a 10 is a negative 10x cubed. And then this would be, you'd have, again, negative x times negative x times negative x, which is negative x cubed. But then you're taking it times a negative 10. So that's a positive 10x. I'm sorry, shoot. That was supposed to be a squared. Okay, try it again. Negative x times negative x is positive x squared. So I have a negative 10x squared. Now let's compare like I did before. This was a positive 10 and then a negative 10. The positive switched to a negative, but the negative here stayed negative. Every sign would have to change. Since they didn't, there's no symmetry to this whatsoever. So if I come up to my problem and I plug in a negative 4 right here, or sorry, a negative x right here, this is going to be 9 times a negative x to the 4th. 4 negative x's makes it a positive x to the 4th, so I'll have a positive 9x to the 4th. If I end up with what I started with, that makes it even. And just to prove it to you, that's not it. Where is it? Here it is. It is even. How'd that do? There you go. And then, of course, this is one where you have to explain your answer. So good luck with that.